Okay, so this is the recap on the chapter of heat transfer. Okay, I need you all to recall and think about what we have gone through and what is going to be important. And I'm going to ask you all to play the role of a teacher. Imagine you are going to set a WA for your students. What kind of questions would you set? So, because if you know what your teacher is going to be setting, what kind of question, you can then prepare yourself for it, isn't it? Okay, so in the first part of this chapter, what is important? I'll kickstart. Temperature. The definition. The other concept is heat. What is heat? Again, we have the definition and we have the units. And remember, we have a table that actually does the comparison between them. Okay, so this is for the first part of this chapter. It can be found in 10.1. Yeah, it's a recap. Recap is a summary. Okay, so 10.2, we are talking about effects of heat transfer, whereby we talk about expansion and contraction. Okay, we also talk about the application of it. Right? So to give some example, do you all know any examples of the application of heat transfer? Remember the gaps in the railway, right? Why do we need those gaps? Okay, then also a very important one, which I suspect they will set. I'm not setting the paper. It's very important. Is your thermocouple, right? We have two kinds of metals and one expand more than the other. Yes. Oh, sorry. It is actually called a bimetallic strip. Okay? It's called a bimetallic strip. The bimetallic strip is very important. I think usually teachers will set 2 or 3 marks question for this. They'll ask you, hey, what is a bimetallic strip and how does it work? Right? Then they may give you a circuit which it will help to actually turn on or off the circuit. Okay, so this bimetallic strip is used in fire alarm. It is also used in your oven to control the temperature. Okay, to control the temperature. We also need to consider solid, liquid, and gas. Which one will expand more? Which one will contract least? Right? And that the explanation lies in how the particles are arranged. Okay? How the particles are arranged. Are they close to each other? Is it easy to pass on the energy to the next particle? Or they are very, very far? I think I give a few examples, right, of you all being in school, then I ask you all to pass the message. Okay? So with that, we can actually go into 10.3. 10.3 are the heat transfer we are going to talk about the heat transfer process. And we have three processes. Are you all able to recall what are the three processes? First one is conduction. Second one is convection. The third one is radiation. So shall we talk about conduction first? Remember what is the keyword? What do you think of? Conduction, what do you think of? What's the keyword? It's about touch. It's about contact, right? Conduction, I need contact. I need to touch the next particle in order for the heat energy to be passed on. So I need the touch, I need the contact, right? So which state of metal is the best conductor? Solid, liquid, or gas? Solid, because the solid particles are close together. They can touch one another very easily. Correct? So we have solid versus liquid versus gas. So you need to talk about how closely spaced the particles are. Okay? Then we also have, what do we need to know about conduction? We need to know the definition. What is definition? We need to know the process. How? Basically, keywords are collide or not with neighboring particles. Okay, so we have covered the definition. What is conduction? It is inside your notes. Okay, how is conduction carried out? Anything else? We also have solid versus liquid versus gas. We also have conductor versus non-conductor. And we also need to give examples. So basically, conductors are metals. Okay, to group them loosely, the non-conductor will be non-metals. Okay. So anything else about conduction that you think the teacher will come up with for the questions? Later on, if you think of anything else, you can also add into your notes. Yes. Sorry, I forgot to record. So the second thing that you need to know is convection. The keyword to think of is density. Okay? Keyword for conduction is touch. Particles must be close to one another. Keyword for convection is density. Okay? Convection, you need to know about the definition, which is again, what is convection? You need to know the process. Now, this process for convection is a very common or popular questions that teachers like to set, because I can easily set 3 marks out of this. So can you all still recall what is the process? How do we describe what is convection, or how is convection carried out? Anyone? The template is V, VDACC. What does V stands for? Volume, density, then the action. Either rise or sink. And then you do a comparison, right? Then follow with a conclusion, which is a convection current is formed. Okay? So this is the VDACC. Take note, it can only happen in fluid. What is fluid? Very good. And you must be able to, this one again I put a star, I'm sure confirm will come out. You must be able to draw convection current. I think I have showed you many times in during the lesson. Okay. Show again. Okay, so I'm going to draw the convection current. So imagine now I have my aircon looks like this. Aircon give out hot or cold air? Cold air, right? So the air here is going to be cold. The air here is going to be cold. What happens to the volume? The volume will decrease. The density will increase. So this cold air will sink. Right? Cold air sink. Where do we have the hotter air? Around here, very far away. Correct? If you want the cool air, where would you stand? Wow, directly below directly as near as possible to the aircon, right now. But if you find that you are getting very cold, you don't want to feel so cold, where will you stand? You stand at this red color position, isn't it? Of course, you may want to go up, fly up to the roof, but you can't. So all you can do is you move away. And when you move away, you find that, hey, I'm not in the way of the cold air. Not so cold. So you feel warmer. So over here, these are the warmer air. And when we do a comparison, if cold air sinks, the warm air will rise. So when they rise, they will take over this space that is vacated by the cold air. And then in turn, they will get cooled down again. So then this will form a convection current. Okay? Yes. Oh no, it's mine. It's my design. What's the third process? Third one is radiation. Radiation, what do you need to take note of? The color. So again, what will they test you on? The definition. Okay? And then you also need to know it can take place in vacuum. Conduction, convection cannot, because we need particles. But this one, radiation is pure energy. So this energy can actually travel through vacuum. Okay? And I'm very sure this will come out. What else? They will ask you, because you are focusing on the color, right? So black is a good absorber and good emitter. What is emit? Give out. If black is good absorber and good emitter, then white opposite poor absorber and poor emitter. But when does it absorb and when does it emit? You will have to ask yourself this question. Where Is it? And did I forget to record? Yeah. So the important thing here is you have to ask yourself, where is it hotter? Do you want it to emit or do you want it to absorb? And thermal energy always go from hot to cold. Okay, so that's for radiation. Then what is 10.4? The factors that affects the rate of radiation. There are three factors. Surface area, the body or surface temperature. What is the third one? Yes. Okay. So now, if surface area, I want to record again. Okay. So you all just look at this.